Cool. We're connected. Okay, here we go. So page 10. Oh, Teddy, you need notes?
Yeah, hold on, let me help you. That's gonna be. Yeah.
Okay, so how do I prove? So I just kind of explained it about a few minutes ago, but to formally prove it, we'll use the difference formula for cosine. So it's cosine of pi over 2 times cos theta, but plus, gotta put a plus, sine pi over 2 times sine theta. And notice I'll just kind of repeat. So I just used the difference formula for cosine, which I'll give to you. You don't have to memorize, I'll give it to you. What's cosine of pi over 2? So 0 times anything, of course, is 0. What's sine pi over 2? Anything times 1 is itself. Do I have it verified now? You bet. So it's a very simple verification process. But think about this as well. Basic trigonometry, right? Makes sense. So now we can just use it whenever we see it. Just go straight to it. By the way, this is also true. The cosecant of pi over 2 minus theta is secant theta. The cotan is tan.
Does it only work with 5 or 2 minus?
Correct. That's it. Correct. Because, for example, here's up. Let's make that tangent x and cotangent. What's tangent x here? 4 over 3. What's cotangent of 90 minus x? Now I can do adjacent or opposite. It's still 4 over 3. Because 90 minus x, I'm now using the complements. That's the word co is short for complement. That's what it talks about. The complements of each other. By the way, I could also swap these. I put tangent here and cotangent here. Secant here, cosecant here. And likewise, I put sine here, cosine here. It works. And I think this is listed under the trig review, but I don't think that was really reviewed because I don't think Mr. Band did this with you guys. Yeah, here we go. So in the trig review, it's all right there. So those are called the co-function identities. Okay, so now you guys know. You guys could just use it. Now let's move on to something else. This is called the double angle identity, which we're going to talk about in a moment. I kind of threw you guys in the deep end with number 12 on Thursday. We could do is this. I won't give you this identity, but you can verify it using the sum formula. You'd agree that's a true statement, right? Sine 2x is sine x plus x. And if you call this like u and v, and if you go up above, all to the top of these notes, see that formula for sine u plus v? It's sine u cos v plus cos u sine v. So what I could do is just use that formula and just say, well, okay. Sine x times cos x plus cos x times sine x. Because again, think about it. X is in u's position. The second x is in v's position. Just like in the formula up here, right? It says u plus v, x plus x. So sine x, cos x, sine x. These are identical expressions now. Sine x, cos x, sine x. Those identical expressions. You got two of them. So what are you going to say? 2 sine x, cos x. There you go. That's it. And that's the double angle identity. So as long as you are given the sum form or difference form for sine, cosine, tangent, you could derive this very, very easily. 2x. You double the angle. X is your angle, double it up. So for example, I don't know what x is here, like maybe it's like 50, something, I don't know. So if I double it, fine, whatever that is. But instead of like actually using calculator, I can just tell myself, well, let's do 2 times the sine times the cosine. Sine is 4/5. That's 3/5. So that should be 2 times 3/5 times 4/5. Ah. So that should be 24/25. In fact, actually, if I were to solve for angle x, TI 84 calculator, there we go. Yeah, if I did it in, let's switch my mode to radians. Yeah, if I did inverse sine of 4/5. Okay, let's switch that to actually back to degrees so it's easier for me to follow. Let's try it again. Okay, if I double it up, okay, and I took the sine of that angle, I get 0.96. 24/25 is 0.96. So I know it works. So that's a double angle identity. Now, those I don't give to you. In fact, you actually are expected to know that on the AP exam. But you can always derive it. Well, actually, they don't give you this. They don't give you the sum of difference formulas either, but they don't expect you to know those formulas. But this one, you'll eventually get the hang of it as you do it more and more often. It just shows up a lot. Okay, so let's move on to new stuff. Let's go ahead and take a look at example 14. Then we'll do 15 is a big one. Then we'll talk about double angle identities after that. Okay, so for 14, I'm going to skip 13. I think you guys got the idea. For 13, I should probably use the sum and difference formulas again. So wouldn't that be sine x times what? So you got that, have that memorized. Plus, let me erase x, I need some space here. Plus cos x times sine pi over 3. And there's still more. I'll switch to red. Sine x times cosine pi over 3 minus cos x at this point, I trust you guys can work it out. What's cosine pi over 3? So 1/2 sine x plus, what's sine pi over 3? So √3 cos x. Hope things cancel or we're kind of in trouble. Again, that's 1/2. But what happens here? Yeah, isn't that nice when it happens? And do things cancel? Yes, they do. So cancel, cancel, half and half. Okay, but remember, we're not verifying an identity, we're solving. So now I'm solving. When will that happen? There we go. That's it. And you're only asked to find a specific answer. So you don't have to give a general answer because you're asked to solve from 0 to 2 pi. So pi over 2. That would be your answer. And very good.
So you did, what became 3/2 of the 9?
By 5-3.
Okay.
Where's that 5-3?
And then you just, oh, I see. Oh, and then the cosine is just from the top.
Right. Correct. Yeah, because you're multiplying the root through to the cos x. So, yeah, kind of a simple equation to solve. Okay, I'm gonna have you guys try example 15. Let me freeze the screen so some people are still thinking about it. Okay, what I want you to do for example 15 is follow the hint. You gotta square both sides. After you square both sides, you're gonna have to do some sort of Pythagorean trig substitution, the trig identity for that. And then solve, you have to give a general answer and then state the third negative solution. So go and try example 15 on the next page. I'm gonna be a little lazy because I actually have the worked out the solutions. It's better handwriting than my handwriting. But I'll give you guys about 3 or 4 minutes. I'll walk around and see if you guys need any help. And the third negative solution. So this is like a kind of a pretty good test question, I'd say. Yeah.
Like the answer that's negative or like the answer that produces negatives.
Sorry, say again.
It's like the third negative, like the solution itself is negative or?
Yeah, solution itself is negative, yes. Yeah.
Are we doing?
So cos x plus 1 equals sine x.
Oh.
Are you are you guys changing sine squared to 1 minus cosine squared? Good. So right side get sine squared x. You'll need to do some factoring afterwards. And by the way, check your answers. One of the answers will be extraneous.
I know my confidence because I think because we forgot to.
Yeah.
Yes. You put it back, we'll get back to the first one. Give a plus one.
Wait, can you say that?
Good. Yes. Well, also the fact that you play back the originals, it won't make sense.
Okay, yeah.
Because you're gonna have 1 equals -1.
Yeah,
That won't make sense, but yeah, it's good.
Yeah.
Is this one of them? So it's like +2.
Correct. Yes.
I don't have like.
You gotta put plus 2.5K at the end.
Do you have to
And that's only the third negative solution.
define K pretty short?
Should just a bit have it. I mean, just in case any of the gym, you know. Well, I think I need to. If someone's getting a little more. Well, no, some people have the flexibility if they want to let K be something else. So yeah, do the finance. Yeah, you should. But all likely, you're gonna make it K's an integer.
One, two, nothing. I looked at it, I was like. If you get a choice in what she's best on He's very ambitious. I think it was the first. It's one of those two options.
Yeah, question.
Yeah, well, you can write all. Oh, no, it's too many hours. I just do this tomorrow.
No, don't do that.
So right, Arsenal's.
Wait, no, I'm leaving it in our forum.
How do we go? Yeah, if you're close. I can play on other ground. There's nothing clear about. Oh, what are they calling it? Flush around. I just played 5-2, the jinx out of there, doing something off. First down solution. Like, and I don't know. No. Well, no, because your imagination.
That's not too close. That's not too close. Yeah, but you shouldn't be doing that anyway. No. Change that on nice. Yeah, I would have to go back to the drawing board. You're making us too confident. Yeah.
Oh, yeah, that is.
How else is cosine?
I don't know.
Okay, I'll show you guys the answers in a moment.
You're right, I'm not gonna kiss my 30 degrees. So I think it's now that you've done, stop fighting without. You get used. No, it's Spanish, because I originally was gonna prep for both. We just fill out the.
Okay, here's what I got. Okay, so square both sides. Verb cosine squared, 1 minus cosine squared, combine everything correctly, you should get 2 cos squared x plus 2 cos x, factor out 2 cos x, you should get that. I think I've seen that for most of you guys. So when this equals 0, using the 0 product property, of course cosine 0 happens at pi over 2 and 3 pi over 2. Cos x equals -1, only at pi. The problem with 3 pi over 2 is extraneous. You play 3 pi over 2 back in the original, you have 1 equals -1, so you have to discard 3 pi over 2. So when cosine x equals 0, we're only going to say pi over 2. And of course, it's pi over 2 plus 2 pi k. Or pi plus 2 pi k. Go with the third negative solution, if you go backwards. So you have -3 pi to -7 pi over 2. Here you have -pi, -3 pi. So 1, 2, 3. So it's got to be -3 pi, third negative solution. So the third negative solution should be -3 pi. Yep, there we go. And I did publish the filled out notes in school. Just always have this kind of check your notes, make sure. But any questions? All right, now let's transition to double angles. Now ready to have this deeper discussion about it. Okay, cool. Here we go. Move this over here. Okay, so multiple angle identities. So we're at the top of page 13 of these notes. Can you read that first paragraph where it says in the last section?
In the last section, we had proven that sine 2x is equal to 2 sine x cosine x, using the sum identity for sine. It turns out that this is one of 5 different double angle identities because it relates a double angle 2x to an expression containing only angles in terms of a single angle x.
Okay, thank you. So we already proved it for sine 2x. Let's now prove for cosine 2x. And then what I want to do is show you 2 variations of cosine 2x. And then we'll do tan 2x using an identity there, summarize it, and then do some algebra and other fun stuff with this. Yeah, I think we totally get to end of page 15. I think we can, yeah, I'm confident we can, once I kind of explain this. So yeah, let's talk about it. So if you think about it, cos 2x. Let's start by saying cos x plus x. That's true. Cos 2x is the same as cos x plus x. But going back all the way back here, we have cos of u plus v. You're replacing u and v with what and what? X and x. So you have cos x, and what operation after that? Good. Think of minus sine x, sine x. So let's do it. It'll simplify. We're good. So if we do that, there'll be cos x times cos x minus sine x times sine x. So that's the double angle identity. Now here's a problem. The problem is that sometimes we do proofs that involve this. Sometimes that might make things more complicated. So we need to have some flexibility. So if you think about it, we know the Pythagorean identity is this. Excuse me. We know this to be true. So what if I just replaced sine squared with 1 minus cos squared? So if I do cos 2x, and let's replace sine squared with, sorry, replace sine squared with 1 minus cos squared x. And distributed, you should get this. Does that make sense? So notice I took this right here and replace sine squared with its identical, that's I call it identity, the identical expression using the Pythagorean trig identity. If I took this identity and moved the sine squared, I'm sorry, cosine squared to the right side, sine squared is 1 minus cosine squared x. We know that. That's good. We're cool. All is good. And then we just simplify. So by the same token, I totally can say this. Cosine 2x. Now replace this cosine squared with what? Yeah, 1 minus sine squared, like that. That's good. So that becomes this, right? So that's yet another variation. So we need to have that flexibility, especially when we're solving equations, double angle, or verifying identities. Okay. Yeah, you can lower your chair. Yeah, they're adjustable. Do you want a nice circle chair? I have a nice comfortable chair. What? Oh, okay, all right. All right. So also think about this. Tan 2x. To make our lives easier, let's just think of tan 2x as sine 2x. Actually, does that make sense? Hold on. No. No, that's dumb. That's dumb. Sorry, guys, I'm like being stupid. Let's just do this. Yeah, thank you. Let's just do that. That's much easier. So that'll be tan x plus tan x. So that proves all the identity. So what I did was I took what I will provide to you. I will give you the sum of difference formulas. So when you're on the test, like, oh my gosh, I don't know the double angle. I'm like, give you the sum formula. Just go drive it. You guys can do it. I'll tell you that. I'll remind you, but I'm not gonna drive it for you. You gotta do it. So we're okay with that? So again, I'll give you some difference formulas. You just derive it from that to get these. Yeah, more.
It's like 4.
Yeah, actually, you could do. Yeah, 4x. You would do something simple. Exact. Right. You do 2x, right?
Exactly double.
Not quite. It'd be actually that's a really good test problem. They get an idea. I will go with that. Guys, yo, Laura, thanks. Here the next test question. Thank you, Laura. I'm just kidding. No, Laura just made your life difficult by it. No. I'll put on Laura's test. Yeah. No, well, but there's identities involved. We're gonna see that actually in examples. We'll see that. No, that's not exactly double. You have to actually go through the motions and work it out. You can't just assume that. No. Okay. No, I always like to tease that way. I tease hard. Don't worry about it. All right. So now let's do some problems. You have to find all values. So you're gonna do general answers. Fine. Let me tee these up and then have you guys work through them. So 2 sine x cos x equals cos x. Here, and I think you guys know what to do next. By the way, please do not do this. Why is that not cool, what I just did? You're gonna lose a solution. Yeah. You gotta move that cosine x over. Yes, 100%. And then factor out. I'll let you guys do the rest at that point. Now cos 2x, remember we had 3 variations. We had one that involved both sine and cosine, one had just cosine, one just had sine. So for part B, of the 3 variations of cos 2x, what would be the wisest to use? Well, no. Of the 3 that we have in the previous page. No. No, sorry, I didn't make myself clear. Of the 3 variations, there's one has cosine squared, sine squared, one has just cos squared, one has just sine squared. Just sine squared, right? Because you want all the same trig function. So the variation I would use for this one would be 1 minus 2 sine squared x. And by the way, what kind of factoring am I going to do here for that one? I'm going to treat it like a what? Like a quadratic. Treat it like a quadratic. Yeah, you're going to probably want to do this. Move all terms from from left to right. Treat it like a quadratic. Yeah, -1. And then for part C, oh boy. For part C, Oh yeah. Oh yeah. Coast. Geez, what am I gonna do for this one for part C? Oh yeah, I got it. Actually, I'm not gonna tell you. I don't want to tell you. Okay, when you get to part C, you got three variations. I'm gonna let you guys figure out variations. I'll let you guys figure out. That was the middle trim.
Yeah. Negative. Yes. Like always. I would like more. Is it in the end? My parents, which they have. So I can do the high biology. I'm like. Actually, for part C, I don't think it'll matter which one you choose. I don't think it'll matter. But I'll let you choose anyway. Okay, I'll give you guys about 3 or 4 minutes, then we'll move on to more notes.
When do we know when Jennifer expands solutions?
Always, always. Back in the original.
But what if it's?
I was talking back in the original.
But what if it's?
Yeah, so for example, you guys have 0 and pi, right? Wait, cosine x is no, cosine x equals 0 at pi over 2 or 3 pi over 2.
Yeah, you want to do that.
And then where would I plug those back in?
The original. Yeah, because for example, cosine of pi over 2 is 0, and sine of pi is also 0. 3 pi over 2, cosine of 3 pi over 2 is 0. Sine of 3 pi is also 0. So that's okay. Sorry. Then for pi over 3, sine of 2 pi over 3 is 1/2. Cosine of pi over 3 is also 1/2. 2 pi over 3, cosine of 4 pi over 3 is 1/2.
So how?
Sorry, we take that. Wait. Oh, that's not correct. Sine x 1/2. That's pi over 6.
Oh, yeah.
Yeah, see, that's why we check. So guys, when we're checking for extraneous solutions, you're not just checking for extraneous solutions, just checking if you just solve the darn question correct, right? Because we can make mistakes with our inverse, with our unit circle stuff. So that's another reason why we want to check.
Gentlemen.
What's that?
We check.
No, I'm asking for all values. I'm asking for all values. Oh, well, those ones as well. Oh, first rotation. Yeah, how we doing? You're great.
When side.
Give us about maybe 3 or 4 minutes. These are some pretty meaty problems.
Not too far and breathe, yeah, the sign of it's.
Is it just a pi relief? No. It's not very hard, it's not. It's not. Wait, I got that. How do I know which one to make it survive? Oh, that's good. I got four entities. Wait, is it like pi relief? That give me notice a lot of great. But that's not.
What identities are we gonna get on the test? I'm just curious.
That's.
I was gonna say, here, hold on.
All of them. Let me write that too.
Okay, sorry about that. Sorry, Chris, question, Charlie, yeah, question?
What identities are we gonna get on the test?
There's some different formulas, that's it.
Just,
The sine u plus v, cosine
Just
u
that.
plus v, yeah.
You're right.
That's negative.
I don't know if my brain just.
Wait, let me try
Thank
to-
you, Anna.
Um,
Gracias.
Yes.
Let's
go ahead.
Like, I changed this to sign to that. Sorry. Need to.
Show,
No, that's not true, because the angles have to be the same. That's sine two x times cos x.
Yeah.
Yeah.
Then what would you?
You gotta replace sine two x with two sine x cos x. Just like having it.
Okay.
Like, shoot him up, then you gotta go with the flow after that. Okay, I'm gonna start showing the first couple for A and B. I won't show C just yet. Let's see here. Okay, here are A and B. Yeah, hopefully you guys got something like that. Cosine x equals 0 at pi over 2 and 3 pi over 2. And those, whoever did this answer got kind of cute and said, well, let's just do pi over 2 plus pi k. That's really cool because it does include 3 pi over 2. But if you wanted to say this, I'm totally okay. Like if you're like, well, here are my answers. My answers are pi over 2 and 3 pi over 2, which is true. And I'm gonna put plus 2 pi k after each one. Cool. That's fine too. Just whoever did the solution key decided to consolidate these two because they were exactly different by pi. Either is acceptable. Either is acceptable. Just so you know. In case still represents every integer or all integers. Or any integer. So for B, that's a quadratic. It's like a quadratic with the leading coefficient not being 1. You guys should be pretty comfortable factoring at this point. If you get this far, you should be pretty comfortable factoring those quadratics. Sine x equals -half, sine x equals 1. Of course, sine is 1 pi over 2. Sine is -1/2 at 7 pi over 6, 11 pi over 6. Yep. And whoever put this answer, said put -pi over 6, I don't care. It's all the same. 11 pi over 6 will be included, so it's better than me. So A and B are kind of like more typical questions. C is a little crazy. Let me show what's going on C. Well, it's not too crazy, I suppose. So the variation here was cos squared minus sine squared, which actually was kind of nice because then you get sine x cos squared x, and you get that on the other side, so you combine like terms. So these are like terms. And that's why you sometimes have to kind of think ahead a little bit. Like see, 3 or 4 moves ahead. Kind of like in a game of chess, you try to look to advance and how many steps there are or how many moves you're going to make to get where you need to get. But yeah, you do that, move the sine cubed x over, factor it out, and recognize that's 1. That's lovely. If you did 2 sine squared x, sorry, 1 minus 2 sine squared x, I think that would have been okay. No, that'd be weird. You did that? Okay. Can I see your work?
Yeah.
Yeah, did it 2 cos squared x minus 1? Yeah, I think we would have got something. Yeah, we would have something similar actually, I think. Maybe. Yeah, you would have. Things would cancel out.
Yeah, we're the school kids cancel, yeah, that's cool. Yeah, please cancel, yeah, good. Yeah.
Look like you're in service.
Yeah, good.
And,
Nope.
Where, if you run out.
You gotta drive it. Just some difference formulas. That's it. That's it. That's what you got. You gotta learn how to drive on your own. Okay, and you should just get 0 plus pi k because every pi value. So, or if you said 0 plus 2 pi k and pi plus 2 pi k, I don't care. You said that. Marie, go. Yeah. So, yeah, what Marie's asking is that because we're assigned 0 at 2 places at 0 and pi, so you can say 0 plus 2 pi k and pi plus 2 pi k. That's fine. This is fine at all. Yeah, that's fine. Yeah, consolidates, right? All right, let's keep moving, guys. Okay. Let's talk about example 2 and then example 3a because Laura asked about 4x. So we have Laura to thank for that. Okay. If we don't get to part B, that's okay. I think you guys get the idea. So let's do example 2, then example 3a, and I think we're okay at that point. I think we've definitely hit our targets for today. Okay, here we go. Example 2. So what quadrant is this in, guys? Q what? Perfect. Love it. So here's Q4. That's 5. That's 13. That's -12. You should know your Pythagorean triples by now. Obviously, I'm covering this with my geometry class you guys saw when you walked in. By now, you're at this point where you can identify Pythagorean triples pretty easily. You want cos 2u? Great. You can use any of the variations you want. I don't care. Let's say I do 2 cosine squared theta minus 1. Fantastic. There'll be 2 times 513 squared minus 1. Doing the math in my head, that should be 50 over 169 minus 169 over 169, which should be negative 119 over 169. I'll slow down because I'm going too fast. Sorry. Okay.
Let's get excited. So any variation could work for cos 2 theta. I chose that variation. And by the way, when you start doing more and more practice, you will have to memorize, but you'll be fine. If you have to write, go ahead, drive to the sum difference formula. Cos theta, we already know is 5/13. Square is 25 169. Well, calculators, okay. 2 times 25 is 50. 1 was 1 over 1, but make it 169 169. Find the LCD, right? That's what it is. Subtract. All's good. Makes sense.
If you actually were to find theta by doing the inverse cosine 5/13 and adjust it for the 4th quadrant, and then double that angle and multiply and to the cosine of it, you get some nasty decimal, which would match with that nasty decimal. So you can always verify your work.
Actually, the funny thing is that I do remember doing these kind of problems. So ask your parents, if any of your parents went to UC, like your parents probably same age, I'm 47, so some of your parents probably same age as me. Ask your parents went to UCs. If they went to a UC school, ask them about the SAT subject test or SAT 2 exams. There's been an exam you had to take for UC admissions that had problems like these. I didn't know this formulas. I'll be honest with you, I forgot this. But what I did was I'd always do the inverse cosine of this, adjusted it for the 4th quadrant, double that angle into the cosine calculator. That means so. So you can always do that too, just say that. But I want you to show, I want to see this work. So this a question like this used to be a multiple choice question on a standardized test for UC admissions back in the day. And they got rid of it because this I could talk to you off about college stuff, but that's another time. But you can always just do the inverse cosine of 5/13, and it'll give you a weird answer, right? But then I would adjust it to give me an answer in the 4th quadrant. Like it might say the answer is like maybe 40 degrees or something. So I'd say, fine, that's 320 degrees, whatever. Now double that angle and then take the cosine of it. And it would spit out a nasty decimal. That nasty decimal is negative 119 over 169. So you can always verify that you did it right. Don't worry, when we do review, I'll show you how you can do that. Next one here. Yeah, just be grateful you don't have to do that for college admissions now. But colleges definitely
way more challenging. And there's no way I would have gone UC San Diego. I will admit that. Like I probably, who knows where I'd be going. So college is definitely a tougher game these days. Tan 2 theta. That's going to be 2 tan theta over 1 minus tan squared theta. And that's going to be what? Negative 12/5 over 1 minus negative 12/5 squared. Which is negative 24 over 5. All over 1 minus 144 over 25. And I kind of want you simplifying that. Are you guys wondering if yeah, I kind of do. So that's negative 24 over 5 times, and that's going to be 25 over 25, that 1 there. You make it 25 over 25. Which is, gosh, negative 119. So you flip it. And those will cancel. And the negatives will cancel as well. It's 120 over 119. Okay, in the interest of time, we'll save the Laura Lynn special for another day. The sine 4x, okay. Yeah. We'll prove that. Actually, it kind of was what you're saying, Laura. It kind of was. It kind of. Sort of. Yeah. But we'll save it for another day. But you guys have enough to do your homeworks. Homework I'll put in Schoology will be more of the same stuff. Just to show you what I was talking about, because you're like, Mr. What are you talking about? It's like test for UC admission. So you had to do the SAT back in the day. So SAT is not required for UC. It's not even looked at, by the way, for UC admissions. But you had to do a test called this SAT subject test. There's a whole bunch here. It was like chemistry, bio, and math. There were 2 levels. I did level 2 because I applied as an engineering major. It looked like this. It's 50 questions you had to do in 1 hour. It was 1995. That's when I graduated high school, 1995. This is right when I started doing test prep. When I started working as a test prep instructor in downtown Palo in 2001, right after 9/11. I was a young buck back then. But you can see some of these questions here. Yeah, you can see like some trig stuff that's going on there. Yeah, it's like more trig stuff, solving a trig. You had a graphing calculator for this test. Yeah. So anyhow, ask your parents about it if they went to UC. So.